Welcome to the stream. This is Jason Watts. We are live from Atlanta, Georgia, and just west of Georgia Tech in West Midtown here in Atlanta. If you're not familiar with who I am, my name is Jason Watts. I am the owner and founder of a little automation company that's actually out of Alabama, where I grew up, and it's called Alpha Industrial Technologies. I've got about 24, 25 years of experience working with Siemens technology, and that's what this stream is about. We talk about all sorts of different topics, drives mainly, but today we're actually going to be talking about some networking topics, so stick around for that. We will also, at the end of the stream, we'll talk about our networking topics. We'll go through, kind of pause on the stream, and then later on we will open up some of the topics that are in chat or in the Discord. If you're not familiar, we do have a Discord server that will be in the link, or the link is in the description. I'm on there a good bit. We've had a lot of topics and like people talking this week and working through stuff, and it's been really awesome. I do want to give a shout out to the members, because there was one member on there that I just saw earlier today helping with it's a S7 200 processor, not 1200, 200 processor, and helping somebody get some Modbus communication going. So shout out to all the guys, and I guess there might be gals in there, but everyone that's in there, and especially for the members, if you're not aware that we do offer memberships on this channel, and memberships, what you get is, as we go through and kind of configure the stuff on stream today, I will be putting links. Well, if we develop a UDT or a data type or whatever, the channel supporter section will get access to those UDTs. And then there's a higher level that actually gets the archives of what we developed today into a portal. I put archives up there, so you get access to that. When you sign up as a member at the highest tier, you get access to the stuff that we develop on stream. Also, additionally, for the members, for those, you may have seen a video that came up that is the start of a business development series that I'm doing for our members. I might periodically drop one of those videos out into the public just to kind of get a little of attention into the memberships, because memberships aren't very much, but they really do get the channel out there. It tells YouTube that the content is valuable, just like if you like and subscribe. So if you haven't liked the stream yet, be sure to smash that like button and subscribe if you haven't, because we do this as much as I physically can do it. I love teaching. So let's get started today. We got Mika, who is one of our longtime members in chat today. What's up, Mika? I can't express you enough when I see your members in chat and everything, how much that just kind of, I love building the community. And that is the reason I do all this stuff, is because there's a lot of stuff that I haven't, I guess, I'm gonna say that I have taken for granted, the fact that like I had someone to teach me when I had my questions, and I had support in these things. And so a lot of people don't have that. And so we're trying to build a community so that we can support each other. So today we are talking about OT networking. And if you're on LinkedIn and you follow me on there, you'll see there was a little bit of I'll call it a discussion that periodically comes up about IT versus OT. And if you're not familiar with what those are, IT is, I guess, it's information technology, and OT is operational technology. When I use those terms, when I say IT, I'm talking about network infrastructure for office networks, maybe servers for accounting databases, things like printers, computers, like in the office. OT is the operational technology. So it is the stuff that actually runs your plant. And while there is stuff that uses the same hardware, the methodology behind what you're doing is kind of a lot different. In that LinkedIn discussion that I was talking about, I was talking to someone that was basically saying that, hey, the hardware is essentially the same, which it is. So why can't we be friends? talking about IT versus OT. And my response was basically was like, we can be friends, but you just have to take it as seriously as we do. and of course, that kind of ruffles a little bit of feathers. I didn't say it exactly like that, but that was the gist of it, was that, I mean, in OT, the cost of a network disruption isn't just someone losing access to their printer or losing access to data. It could literally cost someone their life. And a lot of IT professionals, IT people that have never been on the plant floor and haven't really programmed don't understand that. And my point, and it's kind of the rebuttal to that, was like, I don't see how that's possible. Look, I've seen these things and they don't get it. Because this channel is a drives-based channel, obviously I'm coming from the fact that, hey, I've run 3,000 horsepower mine hoists. We're running processes that have thousands of horsepower and motors that want to just go, you know? And honestly, if a network disruption causes a fault on a drive, depending on how that drive is configured, then it either tries to stop really fast, or all of a sudden that motor has a lot of inertia and it's coasting, and you don't know how that process is going to stop. So sure, a machine designer should design it to where it stops safely, but I don't know that. And so in that comment or in that LinkedIn kind of topic, I was saying, if I see an intern walking down the line with a laptop with an Ethernet cable in his hand, then like, unless they have a good reason for that, then they're probably going to get fired on the spot. And that was a little dramatic, but it's just that mentality of like, hey, I plug into this, I could literally injure someone, kill someone even. And it sounds dramatic, but it's 100% true. So we're going to be talking a little bit about networking and the topics kind of revolving around that. We're going to go through and talk about a couple of the main things that I use personally in Alpha's systems, and then I'm going to show you how to select some of the devices using the TIA selection tool. And then we're going to actually configure those devices inside of TIA Portal. I'm going to show you some of the things, some of the little tips and things. So I'm going to get, I'm just going to get, what am I going to get? I'm going to get Paint pulled up here, right? Paint. I just need a white screen. I just need something white to draw on, because there's a couple of topics that I want to talk about, really subnetting and VLANs. So subnetting, VLANs, and what's called MRP. So ring topology, redundancy. Those are kind of the three things that I believe that all industrial technicians, industrial controls personnel really need to understand how to use these in order to segregate their networks, to protect their networks, because like I said, a network disruption in IT could cause Bob's printer to stop printing. A network disruption in OT can cost someone their life. And so I'm probably just looking at this. I might need to, no, that's fine. I just don't want the stream to drop out quality, which by the way, in this view, I don't know how bad it's only streaming this camera. I have a new camera, and because I didn't have the right cable, I only have a USB 2.0 cable. It's only being able to stream in 720p. So this stream with my face like this, full screen, kind of sucks. So in the future, I've already got one ordered. So in the future, we'll be at much higher resolution. So you can see all of my beautiful perfections of gray hair and yeah. So anyway, let's get to it. Let's talk about subnetting. And we're going to go here, maybe. Yeah, that looks good. I want my face to be a little bit bigger. All right, so I think most people that have worked with subnets have worked, is that going to work? So, by the way, you see me turning around. I've got a new monitor over here that's got kind of like all sorts of stuff on it, and so it's left over from IPPE, so it's really big, and so I have to like turn all the way around to see it. So, let's get in and start talking about subnetting. Most of you kind of have been at least aware of this. Anytime that you go in and actually try to, what's it called, connect. Anytime you try to download to a PLC, the first thing you have to do is like, okay, I'm using this Ethernet connection. I've got to get on the same subnet. And we kind of know that. So normally 192.168.0.x is what we're used to seeing. And so these three sets of numbers, we'll call them octets. That's octets. I guess there's an E in there somewhere. Maybe not. I don't know. But the octets, and we'll talk about why it's called octets, but each one of these represents a bank of numbers, a bank of addresses. And each one of them has a range of 0 through 254 for a total of 255 possible numbers, 0 through 254. So that just so happens to be the value that an 8-bit number can hold. So the maximum number that an 8-bit value can hold is 254 because it starts at 0, goes to 254. Guess what? Octet, 8. So that's why it's called an octet. So when I talk about our first octet, this is our first, our second, third, fourth. We kind of go that way. The reason that is we'll see here in a second. So this, we're used to this set, and we know that, and there's a reason. So these numbers each represents hosts and networks. In this 192.168.0.x, we're very familiar with that because we know that this is kind of fixed. 192.168 is always fixed. And that's because this is what is called a private subnet, private IP address range. And so this private subnet address range has 1 octet available for subnets, or for networks, and then 1 octet available for hosts. And we're going to talk about subnet masks here in a second, but just know that by default, because our normal subnet mask on a 192.168 network is going to be 255.255.255.0. So we have, and again, I will talk about this, but we're all familiar with this. We have to set this subnet mask in order to get our 255 IP addresses for our processes. So normally what you'll have is 192.168.0.1 will be your gateway. And then you can go dot 10 might be your PLC. Dot 20 is your HMI, so forth and so on. Now, you should know that with this subnet mask, if I change this address here, it moves to a different subnet. So if I say a 192.168.1.10, and I set my PC to this value, my PC cannot see anything on these subnets, because this is a .0 subnet, and my PC is on a .1 subnet. If I wanted to, with this subnet mask, I would have to set my PC to a .0 in order to actually allow that communication to go through. So if you tried to ping with that .1, .10, actually, let's do it this way, .100. Because if it was .10 and you change that over, you'd have an IP address conflict because you can only have one IP address. These are some of the basics that I think everybody knows. Well, a shorthand term in order to write this subnet and with a certain subnet mask is to take, and I'm going to clear all of this out. Control A. Here. Oh, actually, I can just do this. Boop. I forgot I was using this tool. So 192.168.0. Say X or 1, and then /24. And that part right here, this slash notation, this shorthand notation, means a subnet mask that masks out 24 bits. Okay, 24. So we have 8, 16, 8, 16, 32, and then 64, right? No, I'm multiplying. That's not what that is. 8, 16 plus 8 is 24, plus 8 is 32. So in total, we have 32 bits here, and we are masking out 24 of them. And so this subnet mask means we are masking out 24 bits. Because if we were to rewrite these numbers, you would have 8, and I'm not going to actually rewrite the numbers, but you would have 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, so forth, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, then you would have your number, because you're taking and masking out 24 of these bits and saying, all right, my hosts, my number of hosts are only in this. So here's the thing. What if we were to change this to 23? Well, it would go here. And this subnet mask would no longer mask this bit out. So that would then open us up to where we have that 1. So now this 1, it could be either a 0 or a 1. So now 192.168.0.10 could actually communicate to 192.168.1.100. So now if we use this subnet mask, which would look like 255, 255, 254, 0. Yes, because it's not masking out this last one. So what that would represent would be this last one would be, it would be a 0 here, and then 2, 3, 4, 5, 6, 7. So, and then if we actually converted this binary number, that would be this here. And so it opens up this bit for that. So if we used a 255 or 254.0, all of a sudden this opens up all of these to be able to communicate. And so what that means is, yes, if both of your devices were using that subnet mask and everything on those networks, they would actually be able to communicate back and forth. Now, guess what? Now there's twice as many IP addresses that it has to navigate. And so there's a higher network load because now you have the potential for a lot more hosts. And so you can segregate out that network just by using subnet masks. Okay? So, subnetting, very important. Setting this stuff up is very important to be able to kind of do some of these technologies. One thing that you might be tempted to do would just be like, well, let me just use a bigger subnet. Well, in the IPv4 subnet range, all of devices of on the planet that have IP addresses have these use these 4 digits, and so you can't just use use any IP address and then expect it to be able to operate correctly. There are certain IP address ranges, certain subnets that allow you that are private use subnets. So one of them is the 192.168. There is a 10 dot subnet. Here, let me just delete all this. So we're familiar with the 192. We have a 10.x.x.x. That basically gives us, this is a private subnet with a lot of potential for hosts. So if you can also have a lot of different networks. So yes, Saif, welcome back to the stream. It is great to be back. And I'll try to be getting more and more topics here, or more and more consistent. There we go, live streams. But the subnet that I actually like to use is 172 dot, and then there is a limited amount of range here. I think it's up to like 36. I can't remember. I should have prepared this, but because it gives me the ability to have a little bit different subnet structure and don't have all of the sheer number of potential subnets here. But I like to use these, something like this, because I could do like a 172.10.x.x, something like that. And here's one thing that I like to do, and I like to use these kind of less commonly used subnets, is I don't like using the 192.168, especially the 0, because you have so many devices that if you just put a device on their default address might conflict with something on your network. And so I almost never use this 168.0 just because if someone plugs in something randomly into your OT network, just trying to figure out what's going on, that default address might be something that steps on something important, and so you would never want to do that. So with that, and as always, kind of in chat, we're kind of talking about these are going to be available. The meat of the content is going to be available later, so you can absolutely go through and watch this later. So that's why I don't use the 192.168.0, is just because of risk of some random device being put on. I tend to use these kind of 172 networks because I've never seen a default device IP address in that 172 range. So that's why I use it. So the next thing that I want to talk about is really about network architecture, because subnetting can kind of delineate out your networks to where you get a little bit of security. If you have a device, you kind of need to know, you need to have an IP address on that subnet in order to be able to communicate. So there is a little bit of security, a little bit of network control just in subnetting. And so subnetting practices are a pretty good thing. But the next thing I want to talk about is is a concept called NAT. And it's called, let me clear this out, NAT, Network Address Translation. And essentially what NAT does, and sometimes you'll see in Siemens land, it will be called IP spoofing. It's another term for that. I've seen it use that. But essentially what you do is you have a device that is, say you have your OT network, and you have a device that is sitting on the OT network, and say whatever your OT network is, say it is like a 117.xx/24. So you're just using these kind of down here. And so this has some IP address that's like say it's .1, say it's a gateway, okay? Well, you can have another device on another network that, say this is like a 192 network, and you have a device that has like a dot on this network, a .10 or a .1 address here. Well, you can set up what's called a NAT, and this guy here can be a NAT device, and you can have communication between two devices, two gateways, and then this translates the data from one network. It translates it into the network so that this subnet can actually determine what can actually use it. The reason why you would want to do this is because if, say for example, you're an OEM manufacturer and you make the same machine over and over and over again, and you have a standard software load for that machine, well, all of the IP addresses and everything on that machine will be the same. Well, if you were to connect up all of those onto a single network, then all of those IP addresses would step on each other. So obviously that wouldn't work. Well, with a NAT device, you can take and put in your box, you can have all of your equipment, but you can have a NAT device here, and everything from the outside, you connect into it, and it regulates those IP addresses. So if this is a 172 network and you're a 192 inside here, this device here is doing the translation. That's called a NAT device. There's a couple of different reasons a couple other different reasons you would do it, like a VPN, a VPN connection like Alpha uses for our connections. We have a privately hosted, it's actually a Siemens product that hosts a VPN server. We have a secured NAT device in our main panel, and it provides us access into our OT network. So we design the OT network how we want to at that specific site. And then we have one point that's locked down and controlled that is a point into our greater OT network at our site. So that's what a NAT device is. So network address translation. The next thing I want to talk about is inside your OT network, there's some considerations that you need to think about. Because remember, we talked about the fact that network interruptions can cost lives on an OT network. It's not just printer failures or server, like you can't get to your data or something like that. Like you can have some real world physical consequences. So we want to try and limit the amounts of disruptions to our network. So I want to talk about two different network topologies and how some advantages and disadvantages of each. So the first is what is called a star or a hub and spoke. Those are the same thing. So a star network or a hub and spoke. And you'll see why they call those. So I got my music going in the background. You should know that I got the beat going. So the reason we call it a star or hub and spoke, because you have your central device, say your server or your PLC, whatever you want, and then you go out to your other network devices. So you have other network devices out like this, out in the field, and you go directly to each one. Okay, so you make a connection if you have, in this case, 3, 6, 8 devices and a central device. You make, this would require 8 ports minimum, because you need to have 1, 2, 3. I know y'all get this. So this is pretty simple. 5, 6, 7, 8. So it requires 8+ ports in order to do this. And you might be tempted to use this type of network, because this type of network in general is fairly the most stable. As long as you can make sure that there's power on this guy and make sure that there's very little chance for a network disruption coming from this guy, then this is a really good, reliable method for communicating out. And so, because if a network disruption here only blocks off communication to one device, so it is a one-to-one failure. So if you have one failure, then you only lose one device. If you have 2 failures, you only lose 2 devices. So this is kind of a pretty robust way of doing it. Well, one of the limitations about this is, because of the number of connections, each device requires a single connection. So you might start thinking, okay, well, I want to group these connections together. For example, how alpha systems usually work is we will have a box out in the field with a network switch, and we will actually be configuring one of these switches here on stream. We will have a remote rack with our ET200, so ET200, and then whatever type of I/O needs to come from that. And then we will have make sure that I don't block this up, another thing with usually our gateway switch with some fiber ports or something, and then our PLC, battery backup. So PLC, then a switch. And again, we'll configure this here in a second. And then maybe this is our gateway. And then this is like battery backup. And then so we would bring one of this here. And then from here, you go out to, maybe you have a drive, something like that. So, and then you could have another panel here with a switch, and it has multiple connections inside the panel, 2 different devices, but there's only one back like that. So this is still technically a hub and spoke or a star, but we would call it a hybrid, because you have a star inside a box, and then you have a star over the whole network. So you have this whole big picture, and then you have a star inside this as well. So it's kind of a hybrid. Now, obviously, if you lose this connection, you lose everything in this box, everything in this star. Well, inside this situation, you probably wouldn't, inside the box, you can't operate one without the other. So that's kind of what you have to look at. I've seen inside these boxes, some controls integrators want a star network with their drives, so they will actually run multiple cables out to each drive. And I see why they do that. I see why they make that decision. But most of the time, if that panel's off, if there's a problem with one of the drives, then you're gonna have a problem with all of them. And here's another thing so that's a star network. There's a second option. So everyone coming in, Rashina, I was talking about the member earlier that was helping out with the kind of the old school problem with Modbus, and Rashina is that. And if I'm not pronouncing your name correctly, I do apologize. But recent member and a longtime contributor in the Discord. So if you're not in the Discord, definitely hit that up. And welcome to Teddy from Ecuador as well. It's good to see our international community coming through once again. So the second type I want to talk about is called a ring topology. And we're going to talk about topology specifically inside a portal here in a little bit. But a ring is where you have a central device, say like our PLC, or our main box, and then you have your devices organized in, get this, groundbreaking, a ring. And so you have one port kind of going out like this. So we still have our 8 devices, right? 1, 2, 3, 4, 5, 6, 7, 8. But on our main port, we're only taking up two connections. Now, in order to do this, you have to have what is called a ring manager. And we're going to talk about this. There's a couple of different ways that you could do this. And this ring, the type that I use, is called MRP. And it is Media Redundancy Protocol. The reason I use it is because it's quicker. We'll go into it a little bit in a second. But just know that if you were to connect up this without a ring manager, you would have major problems. Because in an IP network, every port kind of goes out and kind of you broadcast a message. A lot of devices will actually see that message. And sure, a router can absolutely say, hey, I don't have this device on this port, so it will not send out that broadcast message to that port. And so it kind of learns where stuff is. Well, if that message goes all the way around, all of a sudden you can start getting loops, you can start getting problems, and it can saturate your network. So without a ring manager, you don't want to do this. But with a ring manager, what happens is obviously the biggest thing here is how far these connections are. In a office environment, you're talking inside of a few hundred feet. Well, in the plant that we just started up this past year up in Wabash, you have like almost, I would say 700-800 feet between some runs. So you just physically cannot use copper Ethernet on that. So you would have to run fiber for those runs. All of a sudden, your costs for those runs get more expensive. Terminating fiber is more expensive. It costs more. It requires more technicians' work. And the equipment is more expensive. We're looking at some of that here in a second when we're using the TIA selection tool. Well, using the ring topology, as long as you're able to set up these connections in an actual ring, you can set up a ring manager. And for the most part, as long as you don't have 2 non-consecutive faults or errors, then you keep network stability. And what I mean by that is, say in this ring, we have our ring manager, and this is the ring manager. say we lose this connection. The number of devices that would actually lose communication would be 0. If something happened, if a forklift ran over that conduit and broke that cable, we would lose 0 connection to devices. Because even this here, if the route was going here, it would reroute that data very quickly back around when this was broken, and it would get to that device. So with a cable problem, an MRP ring makes it to where, hey, I don't actually lose any communication. But with some of the diagnostics that we would see later, this device would say, hey, I have a problem. This device would also say, hey, I have a problem. They wouldn't be losing any communication, and we could actually set it up to where that transition that would be quick enough to where we don't even have faults on our network. So, but with Profinet Diagnostics that we're going to talk about in TIA Portal, these switches would report that this cable has a problem. Because what happens if there is a problem here and then you lose this cable? All of a sudden, you lose communication to 3 devices. So you, in a MRP ring, you want to try and limit your faults to a single device, because anything between the 2 devices or between the 2 faults on the opposite side of the ring from the manager, you're going to lose communication to it. And so that is what the MRP ring does. Now, this switching time can be anywhere between 100 to 500 milliseconds. And this is just kind of some general numbers. So 1/10 of a second to 1/2 a second of reconfiguration time on a decent network. And there are some higher performance hardware that can get this down to around 10 milliseconds switching time. Now, we'll talk about this in the configuration of our kind of network devices and how to set up our devices to where, all right, is 500 milliseconds recoverable on our automation network? Is losing data for 1/2 a second, is that okay? We'll have to make some of those decisions, but MRP makes it to where you're only using 2 ports for your communication trunk on your main device, because if you only have 8 devices, that's a pretty cheap switch. If you have 18 devices, that's getting more and more expensive. If you have 30 devices, like we do at our, or 30 or more devices like we do at our plant up in Wabash, that's a really expensive switch, especially with the technology that we have. So using MRP saves you cost, saves you installation time, and it can also save you a little bit of downtime, because in a spoken wheel network, there is no way that cable break is, there's no way to actually have it not lose contact with that device that's out on the other side. With the MRP ring, it can reroute it around. So we're going to talk about setting that up in the hardware. So is that all that I said earlier? I think it is. So we talked about subnetting. Last thing I want to talk about is a concept called VLANs. So we've talked about subnetting, we've talked about NAT devices, we've talked about topologies. And the last thing I want to talk about is what is called VLANs, virtual LANs. And the thing that this does is, a LAN is a local area network. So and you set up a subnet, then it will kind of create a type of LAN. But in the world of OT and IT, you have what are called layers. You have the hardware layer, which is down at the very bottom. You have the hardware interface, layer 2. And you have the software interface, layer 3. And subnetting is actually done at layer 3. So it is done at a higher level. And so you have to have some hardware that kind of keeps up with that. Those are your routers. And with so what VLANing does is similar to what subnetting does, except on layer 2. And the reason you would want to do this is because layer 3 traffic gets passed all throughout all of the, or most of layer 2. So if you have a device that is communicating on one subnet, that traffic still has to pass through the layer 2 and layer 1 of the network. Whereas with VLANs will actually segregate up the hardware layer, that hardware interface, that layer 2. It will actually segregate it to where you can be physically connected to something, but something that's physically connected to the same switch will never be interfered with by that hardware. So the easiest way to think about it is if you have a 4-port switch and you have 2 networks, you have devices that are out here on your IT network, and then you have your OT network here, and you want to set up a VLAN for your OT. You can set up what's called port-based VLAN, and you can use these two for VLAN 2, and then these for VLAN 1. And then you can plug in IT. And then this is the same physical switch, but it is 2 totally separate physical layers. And then this way, there is essentially like you're cutting this hardware in half. And with VLANs, it's on the same physical hardware, but none of this OT or none of this IT traffic can get onto the OT network. It's just not possible. VLANing is a very powerful tool to be able to segregate up networks. But the thing about it is, in this situation, you have this device is actually the physical device itself is on both VLAN 1 and VLAN 2. So it can do things like share information, port forwarding, do all sorts of different stuff that are kind of a little bit more advanced, and we're not really going to go into in this topic. But just know that because this physical device is now on both networks, it can kind of act as a liaison, a gateway almost to the 2 networks. So we can talk about that. I'll just at this point, talking about VLANs, I always talk about how I like to keep Rockwell drives off of my Siemens systems. This is how you do it. You set up the Rockwell drives on their own VLAN, and they could be physically connected to the same layer, because in these big plants that we do, we'll inevitably have some other manufacturer's PLC or drive or something on that network. We tell them, all right, you can be whatever network that you want, your same subnet, I don't care. You can do whatever you want over there. But we're going to VLAN you so that your broadcast messaging, your UDP sending messages that really corrupt and like clog up traffic, guess what? You're not going to mess with our Siemens OT Profinet network. Even though we're on the same physical layer, you're not going to mess with us. So that's what we do. We VLAN off the, like, especially Rockwell drives. And so that's how we do it. And so the next thing that we are going to go through now is we're going to click that, and then we're going to click this. No, this. Then we're going to click this. Because, hey, how you doing? Because we are going to go through the TIA selection tool. And this has kind of been a topic requested, and I have lost my mouse on all 5 screens. Where is my mouse? Here it is. The TIA selection tool has a couple of different ways of running. And you can get it, the cloud selection tool. Apparently the cloud selection tool does not really work well with Firefox. And because I use Firefox, for some reason it doesn't like pull the data. But I know that Chrome works well. I just don't like using Chrome because it just takes up so much memory. But yeah, so I'm actually going to be using the downloaded version of the TIA Cloud or TIA selection tool. And it is a pretty cool little tool that helps you out a lot. I know Lucid has talked about kind of how do you select these tools. He'd be like, just use the selection tool. Well, it can be a little overwhelming, but here's your kind of fast introduction to the TIA selection tool. I'll have to do a whole video on the selection tool because it is quite powerful. It has a lot of stuff in it. So let's get the top screen. Does this have my head on it? Yes, it does. And so, yeah. I don't want to cover up too much because I think that, no, that is good because I have like my little login. Is this my login? Yeah, it is. So, hold up. Let me log in real quick. I didn't realize that it wasn't logged in. Sorry. I am human. I don't know. I just didn't want y'all to all have my email address, and even though it's like pretty much easily out there, and you have access to me in the Discord. So what I'm just logging into is my cPortal login. And the reason I want to do this because I want to show you some of the features that's built into cPortal when you are actually logged in. And so I am using the external tool. If you are using the cloud-based version, then you don't have to do it like this. Like if you're logged into cPortal, like on the support website or something, then you don't have to log in. So we've got our this thing that says in settings you can switch between list and customer prices in the price display. So if you have an account that has not list prices, then you can actually set this up to where it shows you the actual list prices. So that's what this is showing here. So here's my company, Alpha Industrial Technologies. Do you want to display our customer price or list price? We're going to do list price. They're the same for us. But so the first thing that you want to do, you come to this welcome screen. It says, haha, see you in the cloud. We are not in the cloud. But yes, the TIA selection tool, this is totally free. It is very powerful for a free tool. And like I've said, this is the downloaded version. You don't have to do the downloaded version if you're using like Google Chrome or I believe Internet Explorer. But what we are wanting to do, we can go through, and the first thing that I would suggest doing is instead of just diving into the catalog, we're going to talk about different projects. So in the selection tool, everything is built into a project because you can save these to your account and it will save it into either as a file or if you're using the cloud tool, it'll actually save it into the cloud under your login. So if you're building up these bill of materials, if you're building up these systems, you're going to be able to access those on demand just by logging in. So always use a project, always save. And quick little thing, you have groups. You could see here that I can go in and say, add, paste. I can either create a new device, which is a single device, or I can create a new group. If there's a group here, if I click on it, it goes into that group. You can see I'm inside group 1. Go click out up here on the project. Want to rename this group. I can go down to edit, name, networking devices. And Jason. So we're going to do this. Then now we're going to click into our networking devices group. And I'm going to leave it that way just to bother some of you, just so you know. And so now we can click again once we're inside this group to say create a new device. And There's a lot in here. The entirety of Siemens automation portfolio is in here. Everything from your PLCs, your IPCs, industrial controls, panels, drives, RFID. My goodness, it's all here, and it's all in one place to where that you can bring it into these projects. We were wanting to look at industrial communication, so we click on that. Now, I will say, once you finally click on a device, it will bring it into your project or bring it into that group. So that's going to get annoying. I promise you, I will accidentally click on it and we'll have to kind of go back through this. And so it's a little bit annoying. If you want information on something and you're not sure that you want to add it to it and you see this little information, click on the information and do that. Don't necessarily click on it. If you don't see a little information bar, you can feel safe to say, all right, I want to go and look at my industrial Ethernet switches. There are about 50,000 different industrial Ethernet switches in the SCALANCE platform. That is a bit of an exaggeration, but not by much. The way that you can go through this is once you get into the industrial Ethernet switches, if you have the article number, which I will say, if you're all the way out in the catalog, I forgot to say this, and you just go to industrial communication, you can absolutely just search. So like I can't remember whatever the numbers are for it. You can just type them in right there and you can find that number. But we don't know what device we want yet, right? So we are wanting to look at, to figure out what it is. So we're going to use the filters. And what I'm wanting is I need at least 8 ports. And so I'm going to say 8 electrical ports, 2, 3, 4, 5, or I can just go 8. And that is at least 8. Okay. I don't need any optical ports for the one that I'm going to be doing because I have a particular one in mind that I want to find. If you notice the difference between managed and unmanaged, all of the features that I've talked about so far require a managed switch. In my recommendation, unless you are inside of a box and not really connecting out to anything, a higher network, don't use an unmanaged switch. Always use managed switches. They aren't that much more expensive and they give you all of these features. And you'll see the cost difference. Like an unmanaged switch is like $100, whereas a really good managed switch is around $400. And sure, if you're an OEM and your whole machine is $1,000, yeah, then that's a consideration. But if you're on a $1 million project, spend the money and get managed switches. It will save you a ton. So managed switches, we don't really know if we need 100 or gigabit on this. So you can see that we do have options for up to 10 gigabit. This is all in the industrial SCALANCE, but we'll just go with this. I want for this a DIN rail mount, and you can see here we have some S1500 DIN rails. So like the bigger DIN rails. Those are these options. And as you can see, my list over here is starting to pare down. Well, in this, if I were to click on one of these over here, it would add it to my group. I want to click, if I want a little bit of information about it, I want to do this. I want to say, oh, okay, this is a X208 Pro. Oh, I see the image here. That's not really what I'm wanting, and list price on it's pretty expensive. So I'm going to close out of that. I'm going to go down to, because I have experience with it, that this XB208 is your entry level, like good entry level point. And if you notice, this list price here is around $715. That's the list. In the US, if your distributor likes you, you're going to be getting these for about $400 or so. So it's a pretty good deal. But yeah, this again is list price. This is actually what we use in almost all of our panels at Alpha, is this XB208 managed switch. And we're going to use this. So we're going to say use article, and it's going to put that into our device. And we've got that. And so that's our bread and butter. We can use that. And I want to show you now, though, we do have some that sometimes we want to use LC connections on. So let's go back to our catalog. We should still be in our networking devices folder, and you can see that it has now added this XB200 switch in here. So we're going to go to our catalog again, back to industrial communication, industrial Ethernet switches, and this is the part that can kind of get a little annoying when you're doing this. This thing, I want at least 2 optical ports, and you notice immediately it starts to pare them down. And then I want DIN rail mounted, and then now we can actually kind of start to dig into these, because what's the difference between XB and XC? Well, you can kind of go through, okay, what is, first of all, you have X and then XC, XB. What are the differences between these? Let's look at this X308, because it's quite important to know. So, and of course, I get one that's not quite that. So the X series is the previous generation series, and a lot of these will show up in here in the description as a spare part only. If you ever see spare part only, do not put that on a new system. Only use it if you are replacing something like for like in the field. Do not use it for a new system. These X series, just X by themselves, are the previous generation. And the only reason that this one probably doesn't have the spare part only is because there isn't a full featured replacement for it in either the XB or the XC or the XZ, I think, XF. So, yeah, so in chat, we kind of talked about compatibility. One of the things that selecting things and setting this up inside of TIA selection is, if there are compatibility issues with what you are selecting and you have everything built out in the selection tool, it will tell you. And so if for some reason that, and the more detail that you give the selection tool, it will tell you, hey, this is not compatible with this other thing. When we're doing like ET200 racks, for example, it will tell you, hey, you've run out of power. You need to put in this other base unit here. It will actually give you kind of tips and say, hey, catch your problems before you actually have them. So, but basically in the networking portion of it, there's not too much compatibility between, because it's just a networking device. It is a general high-featured industrialized networking device. If you're familiar with the Allen Bradley world, your Stratix switches are literally just brand labeled Cisco switches. So they buy a Cisco switch, mark it up, sell it to you, put a little brand label on it, and that's why they're so expensive. The SCALANCE switch is Siemens built in-house by Siemens for Siemens, and no brand labeling. And it's built by an industrial customer or an industrial manufacturer for industrial customers. That's why, in my opinion, if you're going to go with an industrial network switch, then I don't see how SCALANCE has such better performance for the price. You would be amazed at what you get for the price, especially when comparing to like a Stratix. But back on topic here. With the X series, they are old. You have some XCs and XBs. So we are looking at this XB, and this previous series the device that I use is an XB208. Well, there is an XC208, and just general nomenclature, the 2 is the series, so kind of the performance level. And then it's, if you have a 208, that's an 8 port. If you have a 216, that's going to be a 16 port, whatever. 204, that's going to be a 2 series, 4 port. And then you have your kind of extra stuff, like on this one here, this XB205. So that's a 5 port with ST, and it's a Profinet version. I will say, all Scalance switches are Ethernet IP and Profinet compatible. Now, you have what's called the IRT versions of some that are the isochronous real-time communication. And to be able to do that across a switch, you have to have an IRT compatible switch. Most of the time when you're doing IRT, it's in the same panel and it's on the same switch, and you don't actually need an IRT switch in that case. If you want IRT, or actually, yeah, you would need an IRT if you're going through the switch, no matter what, the managed switch, which has all of the routing. So let's look at the XC version. And the big difference here is going to be the temperature range. So on the temperature range for the XC series, they are the extended temperature range. So C's are going to go to -40 degrees C to positive 70 C, whereas the XBs, let me find one, are going to be 0 to 60. So 0 C to 60. So that is the big difference between the XB and the XC, is the temperature range. So I said that we have some LC connections, right? And so I know, let's look at this one because I think this is actually it. Yeah, because it's SC. And then so you have these SC connections, and if you're not aware, you can take SC connections and convert them into LC connections. So here is a 5-port switch with 3 fiber ports. So as you can see, it's got the picture here. You have 5 Ethernet ports, you have a console port, and then well, I guess that's the console port. You have a configuration port, and then you have your 1, 2, 3 fiber ports. So, and $1,700 list, you'd probably be getting that for around $1,100, $1,200, something like that for a fiber optic. And you get all the information here. And because this is an XB, it has the temperature range 0 to 60 degrees C, which, excuse me, I'm gonna have to get a drink. Water break. I've been talking for, my goodness, an hour, over an hour now. This is a fun topic, though. I think it's something that every controls engineer needs to know, and not enough really understand what's going on here. So there's also some of the things that we could go through in these selection tools here. We talked about MRP. We're going to be setting up MRP, so we need to make sure that anything that we have or anything that we select has the ability to do MRP. There's some other stuff like HSR. There's a different redundancy protocol, and you could see that with fiber ports, like this doesn't have that option. But there's all sorts of different stuff, like MRP with planned duplication. Like there's all of this stuff. So like this is the redundancy section. So this helps you in selecting the correct device just by using the filters, and it'll tell you, hey, there's not one with a DIN rail mount fiber port option with parallel redundancy protocols. So anyway, so we've got that. Let's give ourselves another XB LC, so an SC XB. So let's select this one. This one was the one that we had a second ago, right? Yeah, this one's got the 3 ports. Oh, and this one isn't the one we had a second ago because it is only $1,300. Oh, because, I don't know. It's probably because it has something else. So again, going through and selecting things that you need, we're going to use this article. And final thing that we have our order list here. And for this, let's say we wanted 3 of these and we had 10 of these, then we had 10 XB208s. That seems like a lot, but what we can do is we can export our information, either export in the download manager or specification text, or we can go here. We can export this bill of material as a PDF, as a CSV, or an Excel. And then we just select the print format, and we're going to do contents, properties, limits, blah, 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 all that stuff. So this is everything. This is all the information. So, and we don't really need additional stuff. You could literally go through and take this and export this as desktop. Let's just do this, and then trying to bring this over. Yes. Oh my goodness, everything is going crazy. Okay. So, so here's what we have. So here's our limits. So these are the heights, gives you your actual dimensions. And then there should be, here is our actual bill of materials, our order list, and has all of our part numbers on that. If you had exported this in either an XLS or a CSV, you'd actually get this to where you could do that. So we're going to close that. And then we could also just continue to order. And if you click this, it exports it directly into your cart in cPortal. And yeah, so that's pretty cool there. Just a quick kind of overview of the tools that are available to you inside of the TIA selection tool, because it is quite a tool. So one of the things you might be aware of, the selection tool sizer. Well, inside of drive technology, if you go to dimensioning and configuring drive systems, then you can actually have this drive dimensioning with integrated sizer. So this is the new version of sizer. So the kind of standalone version kind of went away, but it was replaced into the TIA selection tool. And so we may do that some other day, but there's a lot of things in here. And we talked about before, like the IO systems for like the ET200 SP. For this system, we can go through and configure, and it steps you through the entire process. And so you have your consumer view of like things that are consuming power. Yeah. This is the way, if you want to set up a system and make sure that you're selecting the correct components, use the TIA selection tool. It is quite powerful. And the same thing, so you have like messages here. So you've not inserted any electronic module. You also have not inserted a power supply into this device. So yeah, it steps you through. And once you get those things clear, you're good to go. But anyway, we've got our order list. So we added in, went to configure a rail for whatever SP device that we had, and it already put in the mounting rail for it. So just be careful when you're looking at that sort of stuff. But anyway, let us kind of shift over now to the next portion of this. I want to go through and actually configure some of this with inside of TIA Portal. So what do y'all think of the new setup here? Like, tell me what y'all think of the lighting. Finally got my big overhead light under control. So a little bit more dramatic of a setup. So we are going to this. Oh, I'll show you this as well. You kind of see in the background. Oh, I'm covering it up. Camera full screen. You see in the background back there. The little light back there. Guess what? We have, and then of course it doesn't work. Actually have a workbench camera back there. So in the future, when we're doing drives content and everything, we're actually working with stuff back on my workbench, have a separate workbench back there. And so, yeah, we're advancing, chat. Like we're maturing. It's awesome. So let's go into the top screen with my face. So, and I'm going to move my face down here for right now. And because as we're going through this, I want you to be able to see what we got going on here. So I've gone over, started a new device, which I believe there is an expert or an export to device, an export into Portal, so you can actually bring your devices from the selection tool directly into a project. There is an import way, but I just am not very familiar with doing it that way. So what I've actually got over here in my hardware catalog underneath the network components, industrial Ethernet switches, SCALANCE 200, since it's the X200 series, we go to the XB200, XB208, and then we're going to use the standard version, which is the AB2. And we're going to make sure that we have 4.4 version selected here, because 4.4 has MRP for multiple rings in a $400 switch. So you actually have multi-ring management in a $400 switch. You go out there and try to find that with anything else and come back and put it in chat, put it in the comment. I'm sure it might be out there. But so what we're going to do is we're going to toss one of these in here, and we're going to name it, because here in a second, we're actually going to put this device onto Profinet. And the reason we do that is so that we can get Profinet diagnostics. And inside a TIA Portal PLC, you have what is called built-in diagnostics. And if this switch is actually a Profinet device and consumes an IP address on the network and has an assigned Profinet master, then it will actually communicate its diagnostic data to the PLC where you can access, which brings up some pretty awesome stuff once we actually get to that. So let's name this. Let's name it switch main, because this is going to be our, or let's call this switch remote 1. Okay. And we're going to go through and set this thing up. And normally you'd be like, okay, Jason, you have to set this thing up in the web server. These things do have a web server, but you don't actually have to use the web server if they're a Profinet device, because once it becomes a Profinet device, you have this kind of controlling, overarching thing that can actually program them. So once you bring them into the portal, and you set up everything, you can actually download from Portal without needing the Profinet or the web server, which is really cool because of what we're about to do. So we're going to go through, we're going to click here. We're underneath properties. I'm probably going to move my face. Where does my face need to go? I think it needs to go right here. Yeah, because I want you to see all of the diagnostics and everything that we have here. So again, remember, this is a $400 switch. Like, I mean, it is a very inexpensive switch, and you have layer 2, layer 3, you have security, you have Profinet interface. Like, you have all of these things that we're going to go through that are pretty crazy. So the basic portion of it, we do want this thing to be a Profinet address. So normally in your little network view, you go up here, click on this the show addresses label with the little eyeball purple lines, and it brings up all of your IP addresses. Let's go through and set it from here first, because this is kind of the most common way of setting it. I want to show you this. So 172.24. See, I practiced this so that I wouldn't mess all this up, and I still do it. So one of the things that I normally do is in my IP addressing, I tend to have my gateway, my servers, all of those are down 10 and below. I normally put my PLC at normally 10. If I have multiple PLCs, I will go from there. And then that gives me a couple of servers, a couple of computers that I can use down at the lower ends, because it is best practice and sometimes required that a gateway has a lower IP address than the host that it is, depending on some stuff. I'm not fully aware of the exact reasons why that's necessary, but I've just run across it. Always try to have your gateways in IP address like at the very bottom. So 1, 2, 3, 4. So normally I reserve number 1 for my gateway, number 10 for my PLC, and then so 10 to 20 for multiple PLCs, and then above 20 to be kind of our all of our other options. So most of the time what ends up happening though is I have remote racks and all of this, and I build out the PLC infrastructure first, and then I build out these networks. And so they usually end up starting somewhere around 40. And then I'll go like 41, 42, 43, 44 on all my different network switches. Just so that on a really big system, just those simple naming conventions and IP addresses and those things are very important. And we could set our subnet mask to where all of our network switches are on like a 174 or 172.24.10 network, and that's all the networks. And then all of our PLCs and IP addresses and all of that stuff is on a 172.24.11. So we could actually do that to where if we had a ton of networking components, then we could just kind of bump open that IP address range, our subnet mask, Bob, and make it that 254. Then all of a sudden we can put all of our PLC hardware, all of our remote racks, all of our drives, all of that on one full 255 subnet range, and then have the all of the networking components have a 255 subnet range or host range of on that other one. So that's something we can do. I haven't run into one that's quite that big. The project out at Wabash that we did is almost a full octet. There are almost 255 devices on it, and there's probably 180 devices, something like that. And I know you're like, okay, that's nowhere near 255, but when you're used to doing projects like in a lab to where it's 4 addresses, those things kind of start to think on you, or you need to think about. Anyway, moving on. So we've set this IP address here. Now we can actually click on the device. We could also go into device view. Just a little bit better view. You can see, okay, this is an 8-port switch. If we were to click on these individual ones, it would actually be able to show us which ones. So now when we come down to Profinet interface, we should have our Ethernet IP address already set here. A couple of things that we need to make sure that we do. In a second, we will have this subnet networked. That is the Profinet master. Which PLC is the Profinet master on this bus? And so second thing that we need to do is synchronize router settings with the IO controller. So the IO controller is that PLC when we put that in. And if we do this, then it will mean that it will go through, if your PLC is using a router, this hardware will automatically use a router as well. And a gateway router, that's what it's talking about. So in our systems, we use that VPN connection. And so we have to set all of our devices to look at that gateway, because we are definitely not on the same network as like our OT network. And so that gateway, that NAT device that I talked about earlier, is going to be our gateway. And if we set our PLC to use that gateway and we have this synchronized router settings with IO controller, it will automatically say whatever the PLC is using, I'm going to use. And that will save you a lot of headache. Just in order to actually download and go online with a PLC, you have to have that gateway, so remotely, I should say, you have to have that gateway set to whatever your gateway device is, because you can ping out, but remember that NAT device changes the IP address. So the PLC sees a ping coming from .1, and it says, okay, hey, I'm responding to this ping at .1, and it comes back to the gateway, and it's like, what do you want me to do? Like, I don't know where do I send this? It doesn't know where to send it because it's just some like random thing. So using the gateway, using it as a gateway, it says, hey, I want to actually look at that data, and it can actually get out of using that gateway. So I might not have explained all of that very well, but just know that in order to get the communication back through a VPN device, all of your hardware has to have the gateway set as whatever IP address that VPN device is. So we talked about a couple of different things earlier. Subnet being the first one. Well, that subnet is determined by the IP address, plain and simple, and the subnet mask. So if we wanted to talk about that, this is where we would set that. That gives us the ability, that 254 gives us that ability to have a router network and then hardware network if we wanted to, and then them all communicate. We would just have to set all of our devices to the subnet mask 254. And I will say, this subnet mask does not include this gateway. It includes this IP address and this IP address. So it only includes, because remember, that's only one bit, and one bit is a 0 and a 1. So that is a valid subnet mask IP address combination, because this can communicate to this, and they're not the same IP address. So there's no IP address conflict. And so consider doing that. I mean, I probably would consider doing that. I will say there is one issue that I kind of come across with, and this is just from a very high level remote diagnostics standpoint. You end up using, if all of your IP addresses, if all of your OT networks use the same IP address range, the VPN software that we use can actually connect up to 2 different networks at the same time. And so when you're connected to 2 different networks, if they're the same IP address range, then there gets some complexity in there. And so what the device does is it says, okay, I know where you're trying to go, but you need to use a virtual subnet. And so you actually have a totally different virtual subnet, and it can get pretty confusing. And so I tend to have unique subnets for every site on this second octet here, because just so that I keep everything separate and I don't have to worry about virtual subnets in my remote connections. That's only if you're supporting multiple sites, though. If you're not supporting multiple sites, you're probably never really gonna worry about that. So the second thing we talked about was the virtual LANs, right? Did we talk about virtual LANs next? Yeah, I think we did. So what we're going to do is under this, remember we said virtual LANs were a layer 2 system. And as you can go through this, and I encourage you, we're going to talk about like 3 things on this. There's a lot of stuff on these switches, and there's a lot of black magic going on. So we're going to talk about VLANs, and in general, you have 2 options. You have a transparent bridge, which is essentially no VLANs turned on, and then you have a VLAN bridge. So what this does is this is kind of the initial setup, and so you can go through and set up multiple virtual LANs this way. And we're going to say new entry. We're going to say 2. We're going to say blah. Give it another one. It's new entry. There you go. So now we have 3 virtual LANs on this 8-port switch. And so we can either go through here and see these U's. That means that's an untagged member. That meaning that the switch itself knows that those are on the same virtual LAN. So if we wanted virtual LAN ID 1, and we can name this like OT, or we'll say this Siemens. Rockwell. Then IT. Okay. And so what we can now do is, since we have these settings here, we can go through right now. Everything is on VLAN 1, the Siemens VLAN, and VLAN 2 is not available, or same with VLAN 3. Well, say we wanted to have ports 4 and 8 be available for Rockwell consumption. Well, we can go down here to 4 and change these here like this. We're going to say those are off. And this like that. And this would set it up to where now the Rockwell could communicate to Rockwell, and the Siemens can communicate to Siemens. Now, we can also go over to this screen, and we can make changes as well on here to where we set this up. So we want port 4 to be VLAN 2, and then port 8 to also be VLAN 2. And so now we have those set up. We can turn in filtering to where ingress filtering means you can't, there's information, untagged information can't get into the network. And so that's what we're wanting to do. And so we may want to turn ingress filtering on for all of these. So that's what's going on there. So if you're not part of a VLAN, if you're not communicating part of a VLAN, ingress filtering filters your communication. So that ingress filtering means that only communication from a switch, a network that is actually on the network, on that VLAN, is going to actually be able to get through. So that's what that is. So sometimes you might want to turn that off. Sometimes you might want to turn it on, but that's what that means. And that's really honestly it for that. So for VLANs, that is generally what it is. So that is a port-based VLAN setup. And if you wanted this switch to be able to have access to like port the IT network, if you notice, it lets me do this. And so both this port can communicate VLAN 1 and VLAN 3, but it can't communicate to Rockwell. So and let's look at something and see what pulls up if I click F1 here, because I wonder what the help file looks like on this for VLANs. It doesn't really bring it up very much, does it? I know you can't see this. I'm just looking it down and see what actually pulls up. Inside of the web-based management, there's a little question mark that if you're questioning like, what the crap is this? What's going on here? It actually gives you ID to VLAN. Yeah, so let's look at this. Let's look at this help file. Tell you transparent. Yeah, here you go. Here you go. Yeah. So here's kind of the difference between the uppercase and lowercase. So are forwarded without the VLAN tag. So on the other side, then it doesn't know on the other side whether or not that is actually but the VLAN is not configured as a port on the VLAN. So the way that this goes through is over here on port-based VLAN. You can only have that one. And eventually, once this is actually compiled, this should clear up. And so we would want to like take that off. Right. Yeah, see, we have that and that. And so if we go over here, did I put those on the wrong ones? Is that what I'm looking at? So 4 and 5. Oh yeah. Okay, so that's what I did. I put them on the wrong ones. So 4 and 5 are on my, not this one. Actually, port 8 is VLAN 3, right? Port 4 and 5 are VLAN 2. Is that right? There we go. So there, that is set up, all capital U's. That means that they're forwarded with the VLAN tag. So that means that on the other side, you could set this could be a trunk, and then you could get that communication across that VLAN, across to something that isn't really using tags on the other side. And so that's what this is for. At least that's how I understand it. Which, if I'm wrong, please comment and tell me I'm wrong. I had this wonderful user telling me about, or a commenter, I should say, telling me my mistakes in my streams, and I actually do appreciate it. So if I make a mistake, point it out. We'll talk about it because sometimes when you're doing a 3-hour-long stream, you say the wrong things a couple times, and it's on the internet forever. So the next thing that we were talking about was going to be the ring management. So just so that we make sure, we do have a ring on or ports 1 and 5. That doesn't quite work. So let's change this real quick because I don't actually think it will allow me to do that. You can't make a ring on a across VLANs. So we'll do that. Let's go ahead and save this because I'm wanting to create from this port, which is port 1, and then this port, which is port 5. I want to make a ring because we're going to make this MRP ring. And it's actually pretty stinking simple to set up. It is just under ring redundancy. If you click there, make sure that this little box is set up. And I don't know what just disconnected, but something disconnected. Oh, it was my camera. Hold on a second. I have a little technical difficulty here because here, my camera, I think my camera died. Apparently it doesn't charge the battery when we do this. So I may have to go back. So we'll go without the camera for a little bit while it charges, hopefully. Trying to make sure that it is actually charging. Here in a second, I'll change the battery out for the end. But let's just continue on this because we've got the ring ID here, which on this one you can have up to 4 rings, which again on a $400 device, it's kind of insane. So pick the ring ID, pick the ports, and this one, by default it's ports 1 and 2, but we wanted ports 5 because we want it on top, and that's just so that you can actually have inside the panel you can bring your device in, and or bring your cable in and then cable out, and then all of your other devices use the other 6 ports. So the domain, just select MRP domain 1, and you go from there. And I don't know what this standby is, but it looks pretty cool. I want to look into it. There's just always just really cool stuff. And so our ring, that's all it. Oh, so here's one thing. So like an MRP, MRP manager, this will be the central device, and then a MRP client is going to be the devices that are out on the ring. And yeah, so that's kind of the difference between those. It says like automatic redundancy detection. I don't like that. You need to have a manager, and I don't even think it'll let you. I don't think it will let you have a client on it. So let's just leave it right here, and then we're going to take, because we now have these devices that are actually here. So what we're going to do, we're going to take and Control C, Control V, Control V, Control V. So we're going to set up a ring. So we're going to do 41, 42, 43. And so now all of these have these assigned. Now let's go and just throw a PLC in here because I just want to have something. CPU 15, whatever. Doesn't really matter, I don't think. So let's use our 1515 TF that Alpha uses. 1515 TF-2. Drop. While that's loading, I'm going to see. All right, so we all know this. Get out of here. 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 And remember, there is, if you notice, these stinking underscores. You know how much underscores are bane to your existence if you actually are paying attention in Portal, because underscores are an illegal Profinet character. So don't use underscores. I don't know why it does that. Instead of using the dash, use a dash. A dash is fine, not an underscore. So, and so now all we do is we need is that P1? Yeah. So 172 24 0 10. And now, did I put that on the wrong one? Oh, no. Okay. I'm just assigning these to the actual controller because we're about to do something here in a second that it'll make sense. So we're wanting to set up this MRP ring, and so we're going to use the remote number 1 as the, let's go to device view. We're going to use this as the manager, MRP manager. And then now we're going to go through number 2 is going to be the client. MRP client. Number 3, same. And we could have done all of them as client and then just change the 1, but I didn't think that far ahead. And we're done there. So now what we're going to do is, so we look at our network view. If you notice, they look like they're all connected, right? Well, they're not quite connected for MRP. So especially because now that they're actually on Profinet, which, by the way, if you just used the IP address and routing capabilities, like these things would work without being on Profinet. You don't have to have a controller. So these can be used as a standard IT network. You don't have to have a PLC. Just letting you know. Let's go to topology view now, because this is where the real secret sauce of everything is. So let's go to from 1 to 1 on all of these. So I'm just dragging from 1 to 1. Actually, hold on. Let me do this. Delete that. I need to do it a little bit differently. So we're going to go from 5 to 1. 5 to 1. 5 to 1. 5 to 1. And so we now have a ring. Let's see if it compiles. And then we're going to take, and because this is actually in, we're going to move this down here. Move all these over. And then we're going to go from 1, it needs to be this. Because remember, port 4 is on a different VLAN, because it probably would complain about that. So let's compile this. See if it complains. This is live pain if it doesn't. And just so you know, if you have some sort of improper configuration in this topology, it will absolutely let you know at this point. And it compiled. It's probably something like, hey, it doesn't have a protection level. Yep. And no password protection for the safety program. So this actually works. And we can now go back into the device view for these and select, say, remote 1. And now we can actually go through and, whoops, see all of these MRP domain 1. And these others should be the same. MRP domain 1. Yep. So that is literally all you need to do in order to set up ring redundancy with the XB208s. And so, yeah, it's pretty cool. In the meantime, let's look at something. I think that is it for what we want to talk, because that's honestly, at this point, we talked before about when you go to download this network. I do one thing. When you go to download this network, if you're off, you have to be offline in order to download these changes. And obviously it is going to require CPU stop. And anytime that you change the topology, you actually have to physically wire up these connections in exactly the same thing. Otherwise, you will get a fault on this device. So you will get, and when you bring this up online, it'll show this little screen will show red, and it'll say, hey, there's a problem with this connection. And usually it means one of them's unplugged or a device is off or something. And that is how you can actually tell where, if you have a fault on a cable in a ring network. In a star network, if you have a fault on a cable, like if a forklift runs over your cable, then this whole node is going to go down. Well, in a ring, that node's not going to go down, but you're going to have on both sides of it in this topology is going to be complaining about, hey, I don't have a partner on my port. Like a partner, it'll say partner not reachable, partner port not reachable. So if you don't have that, then you're gonna kind of be out of luck. And one of the things that is really cool, if you use a if you use the topology, and I just thought about it, and I should have looked it up before, but it's called device replacement. If you use the what's it called, the topology here, there's a way to actually set this up to where you can replace this switch. Say this switch gets hit by lightning, you plug in this exact same configuration a default switch of the same type. The PLC sees it, it downloads the program to it, updates all of the parameters, and then you're up and running. So, and that's called device replacement without download or something like that. And I thought it was on this, but maybe it's not. But absolutely, that is part of what comes with this, with using the topology. But it can be annoying. But the only way that you can do the ring is properly setting it up in the topology. Actually, that's not true, because that's a function of the switch. The topology is just so that your diagnostics come back into the, like you get the diagnostics for what is in what, and then if you want to do that device replacement. So, but anyway, we're going to take a pause for a second, and I'm going to swap over, because the way that we're going to start doing these live streams is, this is going to be the end of the live stream for the topic of networking. We've got a couple other things that were in the Discord, and just kind of about different things. And what I'm going to do is, eventually this is going to be cut out of the overall video. And so eventually, probably after a couple weeks or so, this content will be made into its own actual video. So I'm going to pause here for a second, and then I'm going to go from there. But I'm going to try to get my camera going first, because I do want that going. So